All right, welcome to the Explainer. Today, we are tackling a massive and honestly a frequently overlooked challenge in modern IT, and that's cloud cost optimization. Specifically, we're going to look at how combining AWS with a Go programming language can literally transform your cloud infrastructure from a confusing, sprawling expense into a streamlined, highly efficient machine. Let's get into it.
Let's kick things off with a question that literally keeps IT managers and business owners awake at night. Where is your cloud budget really going? I want you to think of your cloud architecture kind of like the plumbing in a massive modern house. It's built to deliver exactly what you need, right when you need it. But what happens if a pipe starts dripping behind a wall? Well, you don't see it, but you are definitely going to feel the pain when you get your monthly water bill. In the cloud, unmanaged spending is exactly like that leaky faucet. It just drips away your budget, minute by minute, hour by hour.
So, how do we stop the bleeding? We need a very specific mindset: cloud cost optimization. Simply put, this is the practice of identifying areas of waste and managing your cloud resources to prevent those costs from needlessly adding up. It's not just about spending less, it's about spending smart. It's ensuring that every single dollar you put into AWS is actively working for you, rather than just sitting idle in the background consuming your capital.
Here's our roadmap for this explainer. We'll be covering 1. The hidden cost of cloud, 2. Hunting AWS waste with Go, 3. Strategies to optimize those costs, 4. Some real-world optimization successes, and 5. How to use this to accelerate your IT career. We'll move quickly from identifying the hidden drains on your budget to the exact technical solutions you can use to fix them.
Starting with Section 1, the hidden cost of cloud. Let's look at why cloud computing actually needs management in the first place.
Look, we're facing a bit of a paradox today. On one hand, cloud computing is absolutely essential. You just cannot run a scalable, modern digital enterprise without it, right? But on the other hand, the sheer ease of use, the ability to spin up massive servers with just a click, means that if you aren't managing it properly, those costs are going to multiply way faster than you can track them. In fact, industry estimates suggest that nearly a third of all cloud spend is completely wasted. That's wild. An essential tool quickly morphs into an expensive liability if we aren't careful. Which brings us to Section 2, hunting AWS waste with Go. Now it's time to actually find those leaks. The very first step is identifying the specific culprits. According to the data, the waste in your AWS environment usually hides in 3 main areas. First up, unused resources. Think of these as zombie servers just collecting dust on your dime. Second, underutilized instances. Imagine renting a massive commercial moving truck just to transport a single backpack. You're paying for compute capacity you simply aren't using. And third, inefficient storage. This is like holding on to old, unnecessary data in your most expensive, high-speed storage tiers instead of moving it somewhere way cheaper. This is where it gets really fun. Our primary weapon against these culprits is the Go programming language. By leveraging Go's native concurrency and the powerful AWS SDK, we can actually write a custom, automated detective program. This application will systematically scan through your entire AWS account, rapidly querying APIs to flag exactly where those unused zombie resources, oversized instances, and inefficient storage buckets are hiding out. Go's performance characteristics make it absolutely perfect for this kind of heavy-duty infrastructure sleuthing.
Moving on to Section 3, strategies to optimize costs. We found the leaks, now let's fix them.
Our immediate attack plan comes down to a super clear 3-step checklist. Step 1, resize instances. If our Go program found that we're using a massive EC2 instance for a tiny workload, we scale it down to match our actual needs. Simple. Step 2, terminate unused resources. If a resource isn't doing anything, we don't just ignore it, we ruthlessly shut it down. And Step 3, optimize storage. We clean up our digital closets, moving data to the most cost-effective S3 storage tiers available based on how often we actually need to access it. But beyond that immediate cleanup, you've got to lock in some long-term best practices to keep those costs low. First, use reserved instances. If you know for a fact you're going to need a specific server running 24/7 for the next year, you can commit to that with AWS in advance and get a massive discount compared to paying by the hour. Also, you should definitely take advantage of spot instances. These utilize spare computing capacity that AWS sells at a steep discount. If you have flexible workloads that can survive being interrupted, spot instances are just an incredible way to stretch your cloud budget further. Okay, Section 4, real-world optimization successes. Let's actually look at this optimization in action. Let's pull this out of the abstract and look at 2 totally different use cases achieving the exact same goal. On one hand, we have a company using AWS for website hosting. They applied what we just learned, they resized their instances to fit their actual web traffic, and they locked in reserved instances for their baseline needs. The result? Massively optimized costs. On the other hand, we have a company heavily focused on data storage. By scanning their environment, they identified inefficiencies, optimized their storage tiers, and not only reduced their monthly bill, but actually improved their overall operational efficiency. It really is a win-win in both scenarios. And finally, Section 5, accelerate your IT career. Specifically, I want to talk about some best practices for the Indian IT students watching. Here's the thing you have to realize. Learning how to write a Go program to scan for AWS waste isn't just about saving a company a few dollars. Applying these specific techniques fundamentally improves your overall cloud computing skills. You aren't just learning how to build something in the cloud, you're learning how to build it smartly, efficiently, and sustainably. You are developing a really deep architectural understanding of how cloud resources actually function under the hood. And that leads us to the ultimate benefit here. This dramatically increases your chances of getting a killer job in the industry. Think about it from an employer's perspective for a second. Every single company using the cloud is worried about their monthly bill. If you walk into an interview and can demonstrate that you know how to use AWS and Go, not just to build applications, but to actively identify waste and optimize their budget, you immediately stand out from the pack. You move from being just another developer to becoming a really valuable strategic asset to their business's bottom line. So I'll leave you with this final thought. Are you ready to stop wasting resources and start building your future? We've seen the hidden costs. We've learned exactly how to leverage Go and the AWS SDK as our automated detective to hunt down those zombie resources. And we've mapped out the exact strategies, like resizing and utilizing reserved instances, to fix the leaks for good. Now the challenge is entirely yours. Take these concepts, apply them to your own cloud sandbox, and watch how mastering cost optimization transforms both your infrastructure and your career trajectory. Thanks so much for joining me for this explainer, and happy optimizing.